Okay, so let's get into the why of using Docker. Why is this something that we're bringing up in this course? Well, on this slide, I have reasons to use Docker in the context of regular software systems, as well as some business reasons. And it's important to recall from the architecture section that our machine learning code in any given machine learning system is a relatively small component compared to all the necessary supporting components. So any benefits to a regular software system equally apply to a machine learning system. So these benefits include standardization. One of the biggest advantages to a Docker-based architecture is standardization. Docker provides repeatable development, build, test, and production environments. Standardizing service infrastructure across the entire pipeline allows every team member to work on a production parity environment, which is very valuable. And the mantra here is build once, run anywhere. When we talk about CI efficiency, continuous integration efficiency, we're saying that Docker enables you to build a container image and then use that same image across every step of the deployment process. This means that you can separate non-dependent steps and run them in parallel. This can dramatically reduce the time it takes from build to production. Think about running your tests in parallel and redeploying your code from one test environment to the next. Maintainability is another important point to keep in mind. We eliminate the "it works on my machine" problem once and for all. Parity in terms of Docker means that your images run the same no matter which server or whose laptop they're running on. And for developers, this means much less time spent setting up environments, debugging environment-specific issues, and a more portable and easy to set up codebase. Isolation is another benefit, so Docker ensures your applications and resources are isolated and segregated. Docker makes sure each container has its own resources that are isolated from other containers. If you no longer need an application, you can simply delete its container. It won't leave any temporary or configuration files on your host operating system. There are also security benefits to using Docker. It ensures that applications that are running on containers are completely segregated and isolated from each other, which grants complete control over traffic flow and management. No Docker container can look into processes running inside another container. And we'll consider scalability and compatibility together here. So one of Docker's greatest benefits is that over the last few years, all major cloud computing providers have embraced Docker. So Docker containers can be run inside an Amazon Web Services EC2 instance, a Google Compute Engine instance, Rackspace servers, or VirtualBox, provided that the host operating system supports Docker, which the majority do. And what that means is that you have the option to scale either horizontally by increasing the number of instances, or vertically by increasing the resources for a given instance. It also means that you can make use of container orchestration technologies such as Kubernetes to dynamically scale your containers. And finally, looking at the business reasons to use Docker, cost reduction is an important consideration. So when we talk about the CI efficiency earlier, this also means that it will lower cloud computing bills, and there are also savings on virtual machine and operating system licensing to consider. Okay, so those are some regular software system benefits of using Docker. There are also some machine learning specific benefits and reasons why we think Docker is an important technology to consider in this course. So first of all, reproducibility. By reproducibility, we mean the ability to recreate a prediction given to a customer at any time in the past. This can be critical in order to pass audits, get regulatory approval, understand model errors, and for a host of other reasons. By using a Docker image and associating a version of our system with a particular Docker image, we are able to guarantee this reproducibility in terms of software runtime, operating system version, and all the other dependencies that are encapsulated in our Docker image. Reproducibility is a really important concept in data science, and in the lecture notes we'll link to some talks and resources on this topic. A second consideration is scalability, and this is similar to what I mentioned on the previous slide, where we have this ability to run our containers on AWS, Google Compute Engine, and many others. But when we consider some machine learning specific challenges like training models which require intensive CPU or GPU resources, the fact that we can do this easily in the cloud and scale up and down as required can be a really important benefit and save us a huge amount of time. And then in terms of compatibility, the ability to quickly share models between researchers, teams, engineers is not to be underestimated. And whilst this tends not to be common purely during the research environment, once a model has gone out into production or is being tested in preparation to go to production, it can be very useful to be able to pass a Docker image back to other teams to review any models that have not performed as expected. Perhaps we've picked something up during our monitoring, and again, this ability to just run it locally across different teams and get the same result is a huge time saver. Okay, that's the end of this lecture.